Okay, so in this problem here, we're going to work with our calculator a little bit. So we're asked to sketch the graph of this particular function. Okay, and so I've already taken the liberty to put it into the calculator, and I'm going to just hit graph. And I don't see anything, and this is what often happens. So then students come along and say, oh, my window's all messed up, let's just zoom to standard to see, find it. And again, I get nothing, which is not very helpful. So what am I going to do? Well, why don't I read the question a little bit more carefully? I have to recognize, like, look at this number here. I'm already up to 2,500, which is on the y-axis. But there's also this part of the question here. This here is a hint, actually. This says that the x values for your graph want to be between -200 and 150. So what I'm going to do then is this is going to be my minimum, my min, and this is my max for x. Okay, so I'm going to go -200 and max is 150. And I'll just go, this tells me the tick marks, I'll just go by 50s. Now, that by itself, if I graph, well, I can see a little bit, but there's a great function that the calculator will do. So I set my x min and max, and now if I go zoom to, I believe it's 0, which is zoom fit, what zoom fit does is it goes to your window, looks at your x min and max, and it makes your y values fit these x's. So if I hit zoom fit, it makes my window fit. So now this is -200 to 150, and my window max, I can see where the tops and bottoms of my function actually are. And so that is a quick little trick about zoom fit. But sometimes they ask in a different way. Sometimes they'll give you this same equation, and they'll say graph it on the axis below. And so typically what happens is students just kind of go zoom 6, and then they start to play with the window to try and do it. They're missing the fact that there is a great big giant hint given to them in the question. If they want you to draw it on this window, make your graphical window of your calculator look like this. So make the x values go from -200 to 150, and make them go by 50s. Go by 50. And then my y min, make it -1,000 to 3,000, and make it go by 500s. And so now when I graph it this way, there is no guesswork available. I know that this x-intercept is 50, 100, -150, so it's going to be about here. The other one is going to be about here, and it looks like it's going to go right around here. And if I look for the maximum, it looks like it's a little bit over here, something like that. And so now I look like I am the brilliant grapher, not sketcher, but grapher, because I have a very reasonable sketch of what it actually looks like, because I made the calculator look like the window they were asking for. And this simple little trick using your axes is really helpful because it takes all the guesswork out and you can tell exactly where your graph goes. So that's expert graphing.